So, good day to everyone. My name is Aaron Joseph E. Mijares, and I am here to report about the multiple regression analysis output. This is the output wherein we could use a software to calculate the possible outcome of a specific or a target multiple regression variables so that we could see the product or the expected amount, expected output of a problem with the specific data, of course. And here we go. So, regression analysis is always performed in software like Excel or Minitab. The output differs according to how many variables you have, but it's essentially the same type of output you would find in a simple linear regression. But there's just more of it. We could see here that regression analysis using this analysis would not only involve simple linear regression wherein two variables are being analyzed if they are significant to each other, and there's just more of it. I mean, saying that it is multiple regression analysis means that there are lots of variables or lots of things that you have to prove that if they are really significant, then we could see or get a specific amount of ideal output after we calculate them. So here's the formula for regression, both linear and multiple. First is the simple regression wherein y is equals to b sub 0, which is the constant of the whole data set, plus b1 times the value of x, which is the first type of variable. And the next is the multiple regression wherein you have y is equals to b sub 0, which is the constant, plus b1 x1, wherein there's a constant in multiplying a specific type of attribute plus another constant, and the next one would be b1 x2, wherein you could get another attribute having the same amount of constant, and b sub 0 ellipses b sub 1 and x sub n, wherein there are lots of variables that are involved in that regression. As we have been taught about the past topics about regression, there's a multiple linear regression wherein you have to prove that there are things to consider in doing this, either if they are not significant or significant, depending on the scatter plots or even to the graph that is been able to be created in each comparison, where y is the predictive outcome of the analysis. So this is a discussion about the use and aid of Microsoft Excel in performing multiple regression analysis. So we're here, we can recall that in a multiple regression analysis, we have to do the following manually. First is to generate a list of potential variables until step 7, wherein we should use the best fitting model to make predictions about the dependent variable. But by using the software like Excel or Minitab, we can easily do the task, and this is a tutorial on how to use Microsoft Excel in performing multiple regression analysis. So multiple regression analysis is difficult to do. We're just trying to solve the predictive outcome of a specific amount of data, and with the use of Microsoft Excel, as what I have told you earlier, we can compare and do multiple regression analysis. So here's how. So example, a factory makes three types of products A, B, and C. The quantity of each product makers depends on how much it costs the factory. A data is represented in a span of 19 months when the factory is used. So this is our data involving three types of products of a factory wherein they're gonna use a factory machine, or these are the costs and the products that are made each month for this factory. So if A made had cost for 1,200 models, B made as 800, and C has 1,000 models. Predict the monthly cost for each models using regression analysis. So here's the solution. Since we have to take note of the independent variables and dependent variables, we should get them first from the data. So we have this independent variables, which are the quantities for A made, B made, and C made from the factory. These ones, the A made, the B made, and the C made. Now, we have to discover what's the DV, or the dependent variable. So here is the cost for each month by the factory. Starting from the first month up to the 19th month, these are the costs on the left hand side. So putting them in a Microsoft Excel would look like this. So this is an example wherein all of our data is put into the Microsoft Excel. And by using Microsoft Excel, we can easily perform multiple regression analysis. So next, now using Excel, we can directly use the regression tool that Microsoft Excel provides us. So let's go to data, then click data analysis. So the upper corner of our Microsoft Excel, wherein we could see data, we have to click that and then click the data analysis, and this menu will pop up, this one. So we will look for regression and click OK. Here's the regression tab that we have seen for that. So another menu should pop out like this. Then you would see here that there are Y range and X ranges. So always remember that the Y range is always the dependent variable. So here you can see that the dependent variable is the cost, since what we have seen earlier in the problem, we have chosen, or we have determined that the cost is the dependent variable, since it's the one that changes whether A, B, or C made are made or created. So we would only include our dependent variable in that range by clicking that one and then select the values that are under the dependent variable. Yes, so in this case, it is under the cost of dollar column. So it is selected already in this tab. Then select the values that are under the dependent variable. In this case, it is under the cost column. It would look exactly like this. So after we've chosen that one, we can continue. The independent variables are the next one. So we have the A, B, and C made here, which you can see. And every time you click this tiny button here besides the input X range tab. So Microsoft Excel has a feature of doing that. Simply select the data under the columns A made, B made, and C made by doing the same thing of selecting the Y range, but instead use the X range feature. So after using the X range feature, our regression is set after putting all the output range on the desired cell. So here, this is what I meant by the output range. You can put wherever in the cells of the Microsoft Excel where you want to see the result of your regression. But for me, I chose this one so that I could easily see the whole outcome of the regression over here. So after clicking OK, here we have our regression. So after this one, I'm gonna explain to you what would be the important factors in choosing or what to do next. So here we are. This is the summary of the results of the multiple regression analysis. So here, the first column, you can see here the R square and the adjusted R square. Sorry if it's only adjusted, but it is called as the adjusted R square. So you can see the captions there. 64% of variability. After doing the regression, we have this R square. So 4% of variability of y can be explained by the independent variables. So the significance of the independent variables to the y, which is the dependent variables, has 64% of variability, meaning the 64% of y can be explained or being um, coherently significant into the independent variables. So the adjusted R square for the number of independent variables used and the sample size. So this one indicates and tells us that adjusted R square, it is the number of independent variables used and the sample size. Then here, this is the significant F. This is the one important thing for us to continue. For overall F test for hypothesis testing using multiple regression. So, I have already explained this part. Now, significant F is the overall F test for hypothesis testing using multiple regression. So, first we have to create or make a hypothesis testing. So here we're telling that the null hypothesis tells us that A made is equals to B made is equals to C made are all equal to zero, meaning there is no such thing as A made, B made, or C made being created since it is a null hypothesis, it is a negative. And then the alternative would be any of the three independent variables is or are non-zero, meaning A made or B made or C made has in has an equivalent number or not equal to zero. Okay, so going back here, we have 0.001127 significant f. Since there is no indicated level of significance, we set alpha to be 0.05, which is the standard level of significance. So since we have the f test result earlier of 0.001, which is less than alpha, which is equal to 0.05. Therefore, we reject the null hypothesis and we accept H1, which is the alternative hypothesis. Therefore, any of the three independent variables is or are non-zero, meaning one or two or three of these A made, B made, or C made is are non-zero. There are they have a specific amount of number. So if the null hypothesis is failed to get rejected, we cannot proceed to the individual t-test, but we concluded otherwise. So we continue to take the t-test of each independent variable. Here, if we fail to reject the null hypothesis and accept the null hypothesis, we cannot already continue here because it would be pointless for us to continue since we're concluding that the null hypothesis, these three ones would be zero. There's nothing to prove to them that there is a specific number of products or outcome would go. But since we rejected the null hypothesis and accepted the alternative hypothesis, so we can continue to our individual t-test. I would say that the importance of individual t-test would make us determine if there are specific products or specific A made, B made, or C made are equal to zero or there is a significance related to our data. So the next would be the individual t-test. Here we have A made who has the p-value of 0.233, B made of 0.025, and C made of 0.017. So here, having setting the standard of 0.05 of alpha of level of significance, the first one would be the A made, and we're gonna have the null hypothesis of having A made, which is equals to zero, and the alternative hypothesis would be A made is non-zero. Since we could see here that 0.23 is greater than our level of significance, we would accept the null hypothesis. We have failed to reject it. Therefore, we would see here that A made is 0 and not included into our regression analysis later on, because we could barely conclude that A made has no significant, or it is not correlated to the data that we are having. So next would be the B made, which is 0.025, having 0.025 here as the p-value. The same thing of making null hypothesis. Our null hypothesis would be B made is equals to 0, and our null would be B made is non-zero. Since 0.025, which is the p-value of B made, is less than 0.05, our alpha. So we reject null hypothesis. Therefore, B made is non-zero, meaning it has a specific amount of number or constant that it is included into our regression analysis for our second part. This is just to confirm, or this first part is just to confirm what I've said earlier, that if a specific variable is correlated to others, to especially to y, the x ones, so we could possibly add them to our regression final analysis. So next one would be the C made of 0.017, which is less than 0.05. So it is less than 0.05. So we accept the alternative hypothesis, which is C made is non-zero. Reject null hypothesis. Therefore, C made is non-zero. It is included. So here, we have to reapply the analysis in Microsoft Excel, but only include B made and C made. So doing the same thing earlier, we have made another regression analysis. Here's the result. You can see here that the stats are different already, and the p-values are totally the same. They are both included into our formula. So here we have y is equals to b sub 0, which is the constant, plus b1 x1, b1 x2, which is b made and the c made, and our constant would be 35,475.3, which is this one, the coefficient for our intercept, our constant. So here we have b made and c made earlier. If there are 800 b mades and there are 1,000 c mades on our coefficient values. So therefore, the answer would be y, or our predictive outcome would be 45,149 and 21 cents. $45,149.21. So therefore, we can predict that if we be given the historical data that we have 1,200 A made, 800 B made, and 1,000 C made, it will cost $45,149.21 to run and use our factory. So that is all. Thank you.